Hi dear students, let us go to another video from the chapter Chemical Kinetics, and this is the last video from the chapter. With this video, we'll finish the chapter. Okay, let us go to the topics. The topic is homogeneous catalysis, where the example is enzyme catalysis. We already discussed catalysis is two types. Let me check. Catalysis are two types, heterogeneous and homogeneous. Homogeneous means where catalyst and reactants are in same phase. Heterogeneous where catalyst and reactants are in different phase. We discussed the detailed mechanism, initial put and long-wear mechanism of heterogeneous catalysis. Homogeneous catalysis, there are a lot of reactions which we are doing in the homogeneous catalysis, like ester hydrolysis, where ester is dissolved in water, therefore they are liquid state, and we are adding H plus or OH minus, NaOH or HCl or H2SO4, both are liquid solution. Therefore catalyst also liquid solution. Reactants, water and ester are in solution phase, they are also in liquid solution. Therefore ester hydrolysis is a homogeneous catalysis. Sugar hydrolysis is a homogeneous catalysis. And there are some gas phase reactions also. For example, sulfur dioxide plus oxygen in the presence of nitric oxide. Nitric oxide is a catalyst, it is in gas phase. Reactants, sulfur dioxide and oxygen are also in gaseous state. Therefore that reaction also homogeneous catalysis. And one of the most important example for homogeneous catalysis is enzyme catalysis. Enzymes are biological catalysts. Enzymes are protein molecules. These enzymes act as catalysts for our biological reactions or reactions taking place in the living system, maybe in the plant or in the animal or even human. Okay, any molecule which is related to the living systems, that molecules are called biomolecules. The reactions of biomolecules or reaction in the biological system are called bioreactions. That is dealt by biochemistry. Therefore, like our normal chemical reactions, bioreactions also require homogeneous catalysis. This role of catalysis is done by enzymes. We have a lot of enzymes. I have listed some: invertase, zymase, diastase, maltase, urease, pepsin, lactobacillin. Invertase is the enzyme. It is from yeast. It converts sucrose into glucose and fructose. Another one, zymase. Zymase also from yeast that convert glucose into ethanol. Therefore, you take any starch products, any starch item, put some yeast there, finally ethanol will be produced. Kallapam. Do you remember kallapam? Yes, many of you will be familiar with the kallapam because that is starch, aripodi, then yeast is mixed. Fine. Finally, when you keep it for a long time, that yeast will convert some starch into sucrose, to glucose and fructose. This glucose and fructose finally into ethanol. And carbon dioxide is evolved. Because of that, it is soft, very soft. Okay. Yes. Then diastase that convert to malt. That from malt is something of starch, carbohydrate, where starch is converted to maltose. Maltase convert to maltose into glucose. Again, yeast, that's from yeast. Urease, soybean, that convert urea into amino acid and carbon dioxide. Soybean is some kind of beans. Once in the paddy field, once harvesting is over, farmers will grow some soybean, and they will plant it as with that soybean because they want to keep that soybean in the soil for converting urea into urea is a fertilizer into amino acid. Amino acid so one of the important component for fertilizer for plant growth. Then pepsin, not Pepsi, pepsin, that's from stomach that convert protein into amino acids. We are having a lot of proteins. Meat is a protein. Fish items are protein. Therefore, our protein content of the food is converted to amino acid by pepsin. Lactobacillus is from milk. It's an enzyme from milk that convert the milk into curd. If you keep the milk for a long time, it will be converted into curd. That process has been catalyzed by this enzyme. Okay. Now, characteristics of enzyme catalysis. Characteristics of enzyme catalysis. Enzyme catalysis has some specific characteristics. Let us learn something. The first is it is highly specific. Highly specific. Second, highly efficient. Because almost 100% efficient. Then, it has an optimum temperature. That is 25 to 37 degrees centigrade. Once we affect the fever, suppose we are affecting fever, digestion will not be proper. Because digestion is a best chemical change. This chemical change is catalyzed by a lot of enzymes. When temperature, during the fever, body temperature increases. Because of that high temperature, many enzymes have low activity, low efficiency. Because of that, our digestion will be affected. That is why we recommend that during the fever time, you use light food, not heavy food. Don't eat biryani or chicken fry like that. Only eat kanji or something like that. Because only light food can be digested. Because many of our enzymes will be dysfunctional or less active. Because enzyme catalysis depends upon temperature. Similarly, there is an optimum pH also. That is 5 to 7. This is also a problem. When you have the problem of acidity, if you have eat something, you will be vomited. Vomited. You will vomit because of the digestion. Because acidity has reduced the pH inside the stomach. Because of that, the lower pH digestion has been affected. Okay. Now it is enzyme catalysis. Enzyme catalysis is promoted or increased by cofactors or activators. Activators are vitamins. Cofactors or coenzymes are metalloids. Certain metalloid, for example, sodium ion, increase the catalysis of certain enzymes. Similarly, certain vitamins have the very critical role in our human body. Similarly, vitamins also have the body. They also have the role that they will activate. They will promote the activity of enzymes. Okay. Yes. And the enzyme is it is inhibited. Enzyme catalysis is inhibited or poisoned by substance such as drug. You have the chemicals which can promote the activity of enzyme catalysis. Similarly, you have the chemicals which will decrease or inhibit or poison the activity of enzymes. Both are possible. Okay, that is called inhibitors. Suppose you have some disease because of overactivity of enzyme, or suppose the activity of certain enzyme, you want to block that activity of enzyme. Specific drugs are available for such functions. Okay, these are the some properties of characteristics of enzyme catalysis. One is highly specific, highly efficient. They have optimum temperature, optimum pH. It is promoted by cofactor or activators. Cofactor is metal ion, activators are vitamins. Then inhibited or poisoned by substances such as drug. Now, mechanism of enzyme catalysis. Syllabus has just mentioned only Michael Menten equation, Michael-Menten mechanism. Michael-Menten equation. Okay, this the derivation of this topic is not important because syllabus has said only mention only. Therefore, I just keep the mention. Rate of an enzyme catalysis is equal to K0 into E0 concentration of substrate divided by Km plus concentration of substrate, where E0 is the initial concentration of enzyme. That's a constant. S is the concentration of substrate. Substrate means reactant. Here the meaning is reactant. The reactant which reacted with this enzyme is named as substrate. Km is called the Michael-Menten constant. Okay. Now, just for more understanding, particularly you might have this equation. There are some question from JAM examination like that. That is, when the higher when K, this concentration, substrate concentration is very less. Substrate concentration is very less. Therefore, the term is R is equal to K0 E0 S divided by Km. These all are constant. Therefore, it is a first order. But if it is reverse order, Km, therefore R is equal to K0 E0 S divided by S. S and S cancelled. This is zero order. Therefore, at the high concentration of substrates, enzyme catalysis follows a zero order reaction. But at a very low concentration of substrate, it follows first order reaction. Very, very important. Derivation is not the scope of our syllabus. You will learn it in post-graduation level. Very simple. If you want, you can learn it. No problem, because it has same mechanism of heterogeneous catalysis, initial good mechanism. Same. Just follow that. Okay. Therefore, but you remember this equation. And enzyme catalysis is also called, there is a mechanism is called the lock and key model. I give that lock and key model as an assignment for you because you have learned it in higher secondary classes. Please note down lock and key model as an assignment and WhatsApp me personally, and I will mark it as an assignment. Okay, thank you for watching.